So this is another random root locus example. If you didn't watch the first one, I'm going to randomly generate a transfer function. Ooh, that's interesting. Okay. So a very small change from the previous one. We still have two complex conjugate poles, but now we have a non-minimum phase 0, or a 0 that's in the right half plane. And so the only difference from this root locus and the previous one, we got some poles over here. I still have this whole section to the left of my 0 that's going to be on my root locus. And then the only other question, this might be a situation where I don't know does it go to the left or to the right? And so I might want to calculate the departure angle. I mean, let's just do that as a quick learning example. So there are really complicated formulas in most books about how to calculate the departure angle, and they seem all scary. But what we're really saying is pick a point near this pole. And then if I just work in a small circle around there, this angle and this angle are not going to change very much. And so I'm going to define a phi1, which is going to be 90 degrees because it's directly below because they're complex conjugates. And I'm going to define a psi. And I could go in and do some careful math here, but I'm going to guess that psi is approximately 140 degrees. I don't feel like doing the trig right now. So what I know is that whatever angle I leave here at, it ultimately has to satisfy. So my phi2 up here is my unknown. And so the sum of my psi's minus the sum of my phis has to equal plus or minus 180, possibly with 360 degree things thrown in there, in order to satisfy the phase condition. So if I just plug in this formula and treat phi2 as unknown, I've got 140 minus 90, which would take me down to, well, let me just do this. So plus 50. Positives and negatives, yo. So 50 minus phi2 has to equal plus or minus 180. So phi2, if we were aiming for plus 180, would have to be negative 130. And hopefully these will work out to be the same. Or if we were aiming for negative 180, then phi2 would be a positive 230. Yeah, and so those add to 360, so they're the same. Either way, I'm taking off at minus 130. Okay, so I'm looking, it's got to be a mirror image about the real axis. Always complex conjugate roots. So I think my root locus looks like that. Let's jump over to Python and verify. Yeah, okay. So, would it have made a huge difference if I went off to the right instead of off to the left? Maybe not a ton, but this does say that I can use proportional control for a little while and improve my performance for a certain range of k, as far as where my pole locations are and increasing the damping. But that if I do too high of a k, it's eventually going to go unstable. So yeah, I call that good for random root locus example 2.